Okay, so find the coordinates of the orthocenter of the triangle with vertices -1, 5, 4, 4, and 1, 1. So the first thing, after I turn my tablet on. All right, so the first thing that we need to note is that we are looking for the orthocenter, right? So if we're looking at orthocenter, that means we should be talking about altitudes, right? And if we're talking about altitudes, then that means specifically we should be looking at slopes because altitudes are perpendicular. And altitudes go from the vertex perpendicular to the other side. And you can draw the triangle if you want to. You don't really have to. It's not necessary. So I know I'm talking about slopes, so I'm going to start by looking at the slopes. So the slope from F to G is going to be 4 minus 5 over 4 minus a -1. So that's going to be -1 over 5. Then the slope from F to H is going to be 1 minus 5 over 1 minus a -1. So that's going to be -4 over 2, which is -2. And then the slope from G to H is going to be 1 minus 4 over 1 minus 4, which is -3 over -3, which is 1. Follow me so far? Okay, so these are my slopes of the actual lines that are on the triangle. So then when I talk about orthocenter and the altitude, then I need to find the slope of the line that's going to be perpendicular. Now, I'm going to specifically look at this line and this line. Why do you think I picked those two? Because they're whole numbers, right? We want to work with numbers that are easy. Let's not make it hard. All right. So the slope of the line that is perpendicular has to be the opposite of 2. -2 is 2, and then the reciprocal is 1/2. And then a slope that's perpendicular here, opposite of 1 is -1, reciprocal is -1. So those are going to be my slopes for the altitudes. Okay. Okay. Then my altitude has to go from the vertex perpendicular to that side. So if the side is FH, then the vertex would have to be 4, 4. Does that make sense? And if the line here is GH, then the vertex has to be -1, 5. So I don't know if that makes any sense. So actually, let me just sketch a real quick picture. I'm gonna put it over here on the left. And it's definitely not going to be perfect. All right, so we have -1, 5 will be somewhere up here. F, then I have 4, 4. Put that here. And then I have 1, 1. So here's basically what my triangle looks like. All right. And so then I need the line that's perpendicular to FH. So that's going to be, I'm going to put it in purple because I'm using purple there. So that's going to be this one. It's probably going to be something like that. So this one, and then the one from that's perpendicular to GH, that's going to be this one. And then I'm trying to find this point right here. And that's definitely not drawn to scale or accurately, but that's what I'm looking for. Okay. All right. So then I need to come up with the equations for these two lines. I need to come up with the equations for these two lines. So I'm going to put one over here. So I'm going to do y minus 4 is equal to 1/2 x minus 4. So y minus 4 is equal to 1/2 x minus 2. And so then that equation is going to be y is equal to 1/2 x plus 2. Does everybody agree with me and see that? All right. So then with this one over here, I'm going to have y minus 5 is equal to -1 times x minus a -1, which is y minus 5 is equal to -1x minus 1, because this is plus and then negative, so minus 1. So then y is equal to -1x plus 4. Okay, so now I have two lines, right? And in order to find the orthocenter, I need to know where those two lines meet. So they're both equal to y, and because they're both equal to y, I can set them equal to each other. So 1/2 x plus 2 is equal to -1x plus 4. So I'm going to add 1x on both sides. Okay, so sorry, I was looking at something else. Okay, sorry, y'all. All right, so that's going to be 3/2 x plus 2 is equal to 4. So 3/2 x is equal to 2. I'm going to multiply both sides by 2/3. So x is 4/3. So I have a value for x. Now I need to get a value for y. So y is equal to -1 times 4/3 plus 4. So that's going to be -4/3 plus, I'm putting 3 down here and put a 12 because 12/3 is 4. So 12 minus 4 is 8. So y is equal to 8/3. That's my value for y. So then my orthocenter is going to be 4/3, 8/3. Questions? All right, the next one, the second one. So triangle RST, RU is the altitude. So if RU is the altitude, the first thing I'm going to do is go ahead and put a right angle here because it's the altitude. And SV, this line here, is the median. So if it's the median, then that means that these two segments are congruent. So that's information that I have just from the instructions. So it says find y if the measure of angle RUS is 7y plus 27. Well, here is RUS right here where I drew my right angle. So that means that 7y plus 27 has to be equal to 90. So 7y is equal to 63. So y is equal to 9. And then it says find RV if RV is equal to 6a plus 3. So that means that this is 6a plus 3. And RT is equal to 10a plus 14. So that means that this whole thing is 10a plus 14. But we know these two sections are equal. So that means that this is also equal to 6a plus 3. So then I can do 2 times 6a plus 3 has to be equal to 10a plus 14. So that 12a plus 6 is equal to 10a plus 14. So 2a plus 6 is equal to 14. 2a is equal to 8. So a is equal to 4. So now if a is equal to 4, I need to find RV. RV is equal to 6 times 4 plus 3, which is 27. So make sure you answer the question, because on the last test, that was a big mistake that people were making. They were able to find the X, but then didn't plug the X back in. So do make sure that you do that. Are there any questions? We have this written down. All right, let's get into our notes for today because they're fairly simple. Shouldn't take too much time. All right, so how are the sides related to the angles of a triangle? That's what we're trying to figure out. We're going to figure that out using inequalities. So we're going to apply properties of inequalities to both measures of angles and relationships between angles and sides. Excuse me. So your definition of inequality says that for any real number a and b, a is greater than b if and only if there's a positive number c such that a is equal to b plus c. So basically, if 5 is equal to 2 plus 3, then 5 is greater than 2 and 5 is greater than 3 because I can add a number to make them equal. Excuse me. So we need that information in order to help us with inequalities and triangles. So the definition of an inequality and the properties of inequalities can be applied to the measures of angles and segments because they are real numbers. And so if you look at this picture on the left, we're looking at angle 1, 2, and 3 in exterior angle theorem, which we talked about way on the first day we started triangles, says that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3, right? So because those are equal, then I know that angle 1 is greater than angle 2, and angle 1 is also greater than angle 3. So what I did was I took the exterior angles theorem, applied the definition of inequalities, which I can do because they are real numbers. So the exterior angle inequality theorem, because first we had exterior angles theorem, but now the exterior angle inequalities theorem says that the measure of an exterior angle is greater than the measure of its corresponding remote interior angles. So in this particular case, the measure of angle 1 is greater than measure of angle A and the measure of angle B. But notice we don't talk about angle C because angle C is not one of the remote interior angles. It's touching angle 1, so it can't be included, okay? We're not talking about that relationship. So use the exterior angle inequality theorem to list all the angles whose measures are less than the measure of angle 14. So we have angle 14 up here in the corner, right here. So it tells us that we need to use the exterior angle inequality theorem. So we need to then establish what our triangles are, right? Okay, so let's go ahead and look at the first triangle. Here's the first triangle. And I'm going to keep going so I can see that 14 is the exterior angle for that triangle. So if this is my first triangle, Aaliyah, what angles are less than 14? Aaliyah. Calicia, what angles are less than 14?
Angle 4. Can you hear me?
Speak up.
I said angle 4.
Can y'all hear her? It's not you. I think it's me over here. Okay, go ahead. What'd you say now?
I said angle 4.
Angle 4, okay. And what else? There's one more.
Angle 11.
Angle 11, right? Because those are both the remote interior angles. So 4 and 11 are less than 14. Questions about that? Okay, now I then can say, oh, well, here's another triangle for 14. So now we're looking at the orange one, right? Okay, so if I'm looking at the orange one, what angles would be less than 14? What angles would be less than 14? What angles would be less than 14? Emily. Speak a little bit louder. Yes. Based on now my orange triangle. Angle 2, okay. In what? In 3. So now that one is a little bit tricky because if I'm looking at the remote angles, then I know that angle 2 is a remote interior angle and 3 and 4 together make a remote interior angle, right? But we already know 4 is less, so 3 is less as well, okay? So we've got, I'm gonna go ahead and circle it. Angle 3, angle 2, we already looked at angle 4 and angle 11. There's more. Not so obvious one, or not so obvious ones, but there are more, so let's talk about it. So you have to be able to look at your relationships that you have in the triangle, not just our exterior angle inequalities, because there's other relationships that are inside of this particular shape. Angle number 11 is congruent to what angle? Angle 11 is congruent to what angle? Angle number 9, because they are vertical angles. So if they're congruent and angle number 11 is less than 14, then so is angle number 9. Right. Then angle number 9 is the exterior angle for 2 triangles. The first triangle that angle number 9 is the exterior angle for, I'm going to do in purple. That's going to be this triangle, right? But it's the exterior angle. So that means that 2 and 3 are less than 9, right? But we already know they're less than 14. So we got that one. Then the other one is 9 is also the exterior angle for this triangle here, right? So it's also the exterior for that one, and I wanted to have that line there. So that means that 9, what is less than 9 based on the green triangle? 6 and 7. So because 6 and 7 are less than 9, they are also less than 14. Because they're less than 6, because they're both less than 9. So you have to pay attention to all of the angles in the relationships that you see. Did I skip a card? No? We'll see. Okay. I feel like I skipped number 66. All right. Any questions? I did? I think I skipped one. Okay, I'm gonna go back to it because that will help us, because that was transitive property here. Because if 9 is less than 14 and 6 and 7 are less than 9, then 6 and 7 are also less than 14. So I'm gonna go back to that real quick. Are there any questions on this one? Okay, so I'm gonna clear that out. And then let me go back. So I think I skipped the properties. I did. Okay, so just real quick, properties of inequalities. So the first one is comparison property. This is something that we know. Like, we know how to compare numbers. They can be less than, greater than, or they can be equal to. That's simple. Next one is the transitive property. So we've seen transitive property before when we talked about equality. Transitive property also applies to inequalities, in that if A is less than B and B is less than C, then A is less than C, or the same could be for greater than. Okay? So the same transitive property, now we're talking about less than or greater than. We've also seen addition and subtraction properties of equalities. Now we're seeing them of inequalities. And basically, you can add to both sides and it will not change the true false value of the inequality. So you can add the same thing on both sides of an inequality and it works just like an equality. So sorry, I had to skip those. All right, so now let's go ahead and go forward. Okay, if two sides of a triangle are congruent, then the angles opposite those sides are congruent, right? So that's our triangle base theorem, right? Because we looked at that before. Like, so if we have this triangle and these two sides are congruent, then we know automatically that these angles are congruent based on the opposite sides, right? Well, the same thing applies not just for sides that are congruent, but when we talk about lengths of side. So the longest side is always across from the largest angle, and the smallest side is always across from the smallest angle. Okay. So we may not necessarily know what those measures are, but we can always put them in order from greatest to least based on angle measure or side measure. Okay. So two theorems come from this. The triangle longer side theorem, which says that if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So if I'm looking at this particular triangle, I see that XY is 9 and YZ is 7. So 9 is greater than 7. So the angle opposite 9, which is Z, is greater than the angle opposite 7, which is X. And the same thing will apply when I'm looking at angles. Angle J, the measure is 110. Angle K, the measure is 45. So 110 is greater than 45. So the side opposite 110, which is KL, is greater than the side opposite 45, which is JL. So KL is greater than JL. So list the angles of triangle ABC in order from smallest to greatest. List the angles in order from smallest to greatest. So, Brian Lopez, what is the, please tell me the list of the angles in order from smallest to largest.
C, A, and B.
Okay, I lost my mouse. Okay, there it is. So, angle C, then angle A, and then angle B. Because opposite C is 11.1, opposite A is 14.3, and opposite B is 15.7. So that's going to be in order from least to greatest. Great job. Thank you. Questions? Next. List the sides of triangle A, B, and C from shortest to longest. The sides from shortest to longest. Sydney. The sides from shortest to longest. All right, so we got AC, and then what's next? Shortest to longest. So AC, then AB, and then CB. Because across from, so 45 is smallest, so you need across from 45, that's AC. Then 55, across from 55 is AB, and then 80, across from 80 is BC. So AC, AB, and this is listing the sides. This will be putting them by their lengths. So you can have the bar or not have the bar. So this is specifically the sides. This is specifically the lengths. So that's something that we don't want to make sure we haven't forgotten since the very beginning. Next card, triangle inequality theorem. The triangle inequality theorem says the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So in this particular triangle, if I add PQ and QR, it has to be greater than PR. If I add QR and PR, it has to be greater than PQ. And if I add PR and PQ, it has to be greater than QR. So let's put that to work, see how that goes. So, is it possible to form a triangle with side lengths 6.5, 6.5, and 14.5? So all three inequalities have to be true for you to say yes. So let's start. So we have 6.5 plus 6.5 needs to be greater than 14.5. 6.5 plus 6.5 gives me what? 13. Is 13 greater than 14.5? No, so that is false. So if that is false, then that means no, these do not form a triangle. So the inequality has to be true for all three. Questions? Is it possible to form a triangle with the side length 6.8, 7.2, and 5.1? If not, explain why not. So we have to test all the inequalities. So we're gonna first start off with 6.8 plus 7.2 has to be greater than 5.1. So here we end up with 14 is greater than 5.1, so that one works, right? Okay. Then we have 6.8 plus 5.1 has to be greater than 7.2. So 6.8 and 5.1 give me 11.9. Is 11.9 greater than 7.2? Yes. And then lastly, we have 7.2 plus 5.1. We need to be greater than 6.8. 7.2 plus 5.1 give me 12.3. Is 12.3 greater than 6.8? Yes. So, is it possible to form a triangle with these side lengths? Yes. Questions? Okay, so in triangle PQR, PQ is 7.2 and QR is 5.2. Determine the range of values for PR. The range of values for PR. So our last side, we got PQ and QR. So our last side is PR. So we're gonna say that our third one is just PR. PR, all right? So I'm gonna use that as my third side, okay? So we're gonna go through and do the same process. So 7.2 plus 5.2 has to be greater than PR. So therefore, 12.4 has to be greater than PR. You guys follow me so far? All right, next, 7.2 plus PR has to be greater than 5.2, right? All right, so I'm gonna solve this for PR. I'm gonna subtract 7.2 from both sides, so PR has to be greater than -2. Okay. And then lastly, 5.2 plus PR. Why this thing is not working? Has to be greater than 7.2. I'm going to subtract 5.2 on both sides. So PR has to be greater than 2. Goodness gracious. All right. So here are my 3 statements about PR, right? Okay. So automatically, I can put an X through this one because all distance has to be positive. So that one doesn't really count because it's a negative number, all right? Okay. So now I know that PR has to be less than 12.4. According to this one up here, but it has to be greater than 2. So my range for PR has to be somewhere between 2 and 12.4. Somewhere between 2 and 12.4. Do we see how I got that? Does that make sense? Do we have any questions? Any questions? All right, that is it. So